38. What Ag plus concentration is required to reduce the carbonate ion concentration, CO3 2-, to 8.2 times 10 to the negative fourth molarity by precipitation of Ag2CO3? Okay, so we're talking about precipitation, right? We're given a compound. So anytime that we're making a precipitation, that just means that we're forming a solid. We go to the KSP equation, right? And I had to go into the back of the textbook to find out what the solubility product is, the KSP, of Ag2CO3, which is 8.1 times 10 to the negative 12th. Now, in this case, they're telling us that we have a carbonate ion concentration of 8.2 times 10 to the negative fourth molarity, and from there, we're just going to find the silver plus ion concentration. We do have to assume one thing here, that we are going to be in a saturated solution, because saturated solutions are always the equilibrium solutions, and that's what a K value is, always at equilibrium. Saturated solutions just means that you're at the brink of basically making a solid in your solution, and that's what precipitation is all about. So let's write out the balanced equation. So start with the solid, Ag2CO3, and that's a solid. The solid's going to dissolve into its two ions. They told us that one was Ag plus, and I have a charge, so that's aqueous. And then the other one is CO3 2-, so thank you for that. Balance the equation. Seems like I have two silvers, so I have to put a 2 in front of the Ag. Okie dokie. So now, let's just write out what they gave us. They told us that the carbonate ion was 8.2 times 10 to the negative fourth. So for carbonate, I'm going to put 8.2 times 10 to the negative fourth molarity. And now we want to find out what that Ag plus concentration is. So that's this one. I don't know what it is, so I'm going to label it as X. Now there's two ways of doing this equation, or this problem, right, from here on out. I'm going to talk about one way, and then I'm going to do the other way. The first way that you can do it, and by the way, both ways you'll get the same exact answer. So it's just your preference. So the first way is to take the 2 into consideration by saying, okay, this is 2x, because normally we do take that ratio, and that's totally fine. So if we use the 2x value and we do the math, we will still come out with x equals, because that's what we always solve for. We solve for just one x. Now, the answer to the problem, you would have to go back and times that x value by 2, because you labeled the Ag plus concentration as 2x. Now, if you're pressed for time on a test or a quiz, you might not have time to go back and times by 2. Or, unfortunately, you might forgot about it. So that's why I don't like to use the ratios for this specific problem. Because what we can do is we could just, screw the ratio and just leave it as x, right? Then when we do the whole math, we say x equals, and they match. So you don't have to go back and, do any timesing by 2s or 3s. Just label it as x. Okay. So let's label this as x, right? Now let's bring in the KSP equation. The general one is this one right here, right? KSP equals the products raised to the coefficients. Let's find out our KSP. So KSP equals concentration of Ag plus times the concentration of the CO3 2-. And now just make sure that you're raising them to the coefficients, and that's when you have to take into consideration that you have two Ags. So I'm just going to go to Ag, and I'm going to have to square that one. I raise the other one to the first, but you don't have to do that. So we got Ag as x. The carbonate ion was 8.2 times 10 to the negative fourth, and the KSP value that we found in the back of the text was 8.1 times 10 to the negative 12th. So let's go for it. 8.1 times 10 to the negative 12th equals x squared times 8.2 times 10 to the negative 4th. So the first thing we're going to do is we're going to divide by that 8.2, right? 8.2 times 10 to the negative 4th on both sides. Okay, that gets rid of this. And now we're going to have something equal to x squared. So 8.1 times 10 to the negative 12th divided by 8.2 times 10 to the negative 4th. I mean, very, 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 very close, right? So I guess I'll extend it out. 9.8780. We'll say 4. I guess we'll put the whole number in, right? 87804. 878. And this is all times 10 to the, hold on a second. Let me just pull this out. This is all times 10 to the negative 9th. Technically, we shouldn't really round, in the middle calculations. We have to take the square root to get x by itself, but then you got to do it on the other side, right? And then we come out with just x equals. So let's see. Square root of that answer. And now 2 sig figs, 9.9. 9.9 times 10 to the negative 5th. And that's molarity. And then you see how it matches. So that means that the Ag plus concentration, which is what we were trying to solve for, was just x. And that's 9.9 times 10 to the negative 5th. Molarity. And there you go. That is the silver concentration required for this precipitation. And there you go. I really hope this helped. Let me know in the comments. Subscribe to the channel. Thank you so much for viewing the video. Tell your friends, tell your classmates about this cool YouTube channel. I think it's pretty cool. All right. We're almost at 20,000 subscribers, so that's awesome. Let's keep it rolling. Thanks so much for the support. Let's keep rocking and rolling. Bye-bye.